Hey guys, what's up? Welcome back again in new video in new topic. So in the previous video I have made a video on foundation engineering which is also in the group A, and today we'll be going to talk about the structural engineering portion, right? So in as this is the very first lecture, so I'm just dealing with the basic things that in what basis do the engineers construct the RCC buildings or the constructions, right? So as in many engineering aspects we do have some assumptions, right? So depending upon the same, the engineers make the site plans, do some of the research, some of the field, they collect some of the field data, and accordingly they commence the construction processes, right? So today in RCC basically there are two methods depending upon the which engineers construct the RCC structures, right? So the very first method is the LSM and second one is the WSM. So what sort of thing we're going to be learning in these topics? What are these? The same we're going to be learning in today's session. So let's begin without any further delay. So from the name itself, we can know that what this method means, right? So LSM means the very first point could be we may write limit state method. Limit state method. So from the name it is pretty much clear that in this if we have to construct the structure based upon LSM method, then we have to strain, then we have to make the structure lengthen up to the last point, or we can say up to the limiting point, right? But in WSM we don't consider the limiting point, we just need the structure to be built, not how much cost or how bulky the structure could be built. It is not the point of concern in this method. We just in any way we have to just make the structure and give it to the client, no matter what the cost is, right? So the same we're going to be dealing in this. So its full form is working stress method. The first point is this one. So in limit state method what happens is the stress the stress strain behavior of material is not linear as like LSM, WSM, sorry. So WSM, in WSM, the stress strain behavior of the material will be linear. Linear means what? The stress strain behavior of material. Material means what? Material means uh, both the concrete and the steel. Concrete and the steel. If we draw the stress strain curve, then the graph will be a straight line, right? In case of WSM, but in case of LSM, this maybe not maybe there are some undulations. If we draw or if we look in the graph, then we shall find the same. So the second point is this one. So the third point is as it is not linear, it is linear. So we can say that it is strain based method of construction. So as the material is being strained up to its limit, so we can say that it is strain based method of construction. It is stress based construction. Okay, so the fourth point is as the material is not stressed, right? As the material is stressed, up to the limit means what? There are some of the limits in between those, you know, before the fracturing point. So this sort of thing we deal uh, under the Hooke's law. So, but since the material is stressed up to its limit, so just a point before, so just distance before fracture could happen. So up to that much of the limit, we strain the material in this method. So Hooke's law, Hooke's law is not valid, valid in this method. But here Hooke's law is valid as material is not allowed, right, to stressed, to not stressed, yeah, stress beyond the yield point or yield limit, right? So third point is this one. So in the fifth point we shall talk about the safety factors. So in case of what? In case of in case of LSM, the partial, we introduce a term partial safety factor is considered, but in case of WSM we just consider the factor of safety, not partial, factor of safety. Okay, so moving in the next point. So in this point we shall discuss about one of the assumption is that the plane section before bending remains plane even after bending. So the same thing we can see in the WSM also. Okay, so in LSM, to calculate the what ultimate permissible stress, then we have to consider the allowable allowable mm, permissible stress value. It means that if we have to calculate the ultimate stress value or the permissible value, then we can take the same value, that is the allowable permissible value, during the calculations. But in case of this one, we have to calculate the modular ratio means what? Modular ratio, it is denoted by small m and equals to 280 upon 3 sigma CBC either. Okay, so sigma CBC means what? Sigma CBC means is nothing but just the uh, permissible stress, not compressive stress in in bending, compressive stress of concrete in bending. So first C means compressive, B means bending, C for C refers here what? Compressive. C refers here concrete. Okay, so one true additional point we can also add here. So we can write in LSM we strain the material up to its limiting point. Means what? Smaller sections. Smaller sections could be built, but since we doesn't uh, give emphasis on the limiting point of the material that is up to which you have to stress, so the bulky uh, mm, structural structural sections are expected. Since the smaller sections are being built there, it means that it is economical. It is economical, right? It is economic. It is a little cheaper, expensive than LSM method, right? So okay guys, so in this topic we have discussed about some of the differences between LSM and WSM. So these are simple points, so one can easily go through these and then get some of the ideas. So in the next topic we shall discuss about the designing of RCC beam, columns, slabs, everything we're gonna be discussing in the days to come. So okay guys, hope you liked it, you enjoyed it, and you get some idea of the same. So I shall be very much grateful of the same. So we'll meet in another video with much more interesting topic as like this. So okay guys, thank you so much.